Hey everyone, and thank you for joining the session on deep diving into Direct Lake. I'm really excited to be here today. I think Direct Lake is a fantastic feature. I also think it's a feature that has been completely overhyped by Microsoft, and I do think that it has potential to become what they want to hype it to be. But all of that and more, I hope you'll take away from this session when we dive into Direct Lake together. So first of all, I'm going to do a very short introduction to Microsoft Fabric, because at this time, I assume that most people, if not everyone in the room, knows already what Microsoft Fabric is at the baseline. So hands up, how many here are not completely sure what Fabric is? Yeah, that's what I assumed. So we will go very briefly over that. Then we'll talk about the different storage modes we already have for Power BI and how Direct Lake fits into that. Finally, we'll talk a little bit about data modeling for Direct Lake. We will go deeper into the internals and performance and how we can tweak models for Direct Lake. And of course, there will be, along the way, demos. So I am Mathias Halkjær. On my day-to-day work, I work as a principal architect, helping clients make fantastic data solutions and sometimes just help them move a little bit up the ladder of digital maturity. I'm a Microsoft MVP. I have a, kind of diverse background in a bunch of different stuff. And in my spare time, I do enjoy cooking, everything tech, and I didn't add this, but I also love to play Dungeons and Dragons when I have time for that. So geek and data enthusiast all around. Favorite tools, of course, Fabric, Power BI, Synapse used to be, and SQL as well. So Microsoft Fabric, as we've all learned throughout the last year after the release, is of course this collaboration, this mix of all the tools, of all the technologies Microsoft has been developed for the last many 5 to 10 years, all combined into this one common platform with one lake stitching all of the others together, really enabling us to do everything we want around data in one place. So we can get our data, we can prepare the data, we can actually use it, and it's all managed one place, one platform, one storage format, one file. And this, of course, part of the Power BI that we already know and love. It's a simplified architecture. We don't have to think about all of the complexities of Azure and setting up our own cloud. It's a managed solution. It's a SaaS solution, and it helps us create diverse architectures and things like that. The reason why I want to briefly talk about Fabric as a whole is that at the heart of Fabric, we really do have one lake, which, if you ask me, is the one big innovation, the one true newness of Fabric. Because if we look at all the other toolboxes, all the other experiences, most of them are replications of something we already could do before. But I think the true game changer here is that Microsoft standardized and kind of forced us to standardize on file format, on where we store our data, so on data lake, and on the approach of how we do this. And this is actually, all of these are actually foundational elements of why Direct Lake is even a possibility. Because Direct Lake really utilized the way that we know how our files and our data is stored, we know what format it's stored in, and we know what kind of structure there is around it. So we can, or not we, so Microsoft can utilize that to fast forward that data directly into the dataset. Thereof also the name Direct Lake. So today in Power BI, we already have some different storage modes. So we have, of course, the classical import mode where we'll just load in all the data and the full data set is cached within our model. We have DirectQuery where queries are submitted in real time, giving us access to real-time data from our data sources, but of course with the latency of having to send those queries, wait for that data to come back, then render the visuals with that data, and to be honest, often a laggish, sluggish feel to it when we make reports like that. They're not that fast often. And of course we can optimize by also doing dual storage, so some tables with DirectQuery, some tables with import mode, and that can sometimes be a good compromise. And then we have something new. We have Direct Lake, which will be a new alternative to what we already have, which is being boasted as the best of all worlds. So it's supposed to be the best of import mode and DirectQuery. It's supposed to be, well, the excellent trade-off between the two. And I do think that there is some truth to this statement. Because if we look at import mode, it has to load in that data. So we have our files, delta tables, or wherever our data comes from. It has to load that into our data set. And once that is done, we can then send the DAX queries to it. And it's going blazingly fast because that data is just right there in memory, column store inside that semantic model, which is really what is making import mode fast. And DirectQuery has to, of course, send the queries. It gets the queries from DAX, has to send it back to the source systems, and then it receives the response, and it can render it for the reports. So the neat thing is here, what if we could, and this is actually the way Microsoft presented Direct Lake, and I do want to modify it and show you maybe a more realistic view on how it works. But what they're saying is that with Direct Lake, we skip all these middle steps of queries. We can just send the DAX queries and just send them to the files, delta files directly, and get the results. That's not completely what is happening, but it gives an idea of what it is. It's a shortcut that lets you query your delta tables instead of querying your cache dataset. Truth with some modifications that you'll see soon. So Direct Lake is innately a Fabric feature. So it falls. It often looks like falling into the territory of being a Power BI feature. All the other storage modes is a Power BI feature. So if we're using Power BI Pro, or if we're using Power BI Free, or if we are using Power BI on-prem or something like that, we could wrongly think that Direct Lake is something we also should consider or could be something for us, but that's not the case. It is dependent on having a lakehouse, either a lakehouse or a warehouse, to be able to function. So if we have our data stored in an on-prem data warehouse, or in Azure Synapse, or in Databricks, or in Snowflake, or in some other source system, we cannot really utilize Direct Lake. Technically, shortcuts is also a thing in Fabric, so using those, we may be able to do that, but that's out of the scope of this session. It's a Fabric feature. So without any Fabric, without no Fabric capacity, we will not be able to use Direct Lake. And the consumption that Direct Lake is using is also Fabric consumption. So we're also paying for the model. Same way as how we're paying for our data sets or semantic models in Power BI Premium. So nothing new there, but it is a Fabric feature. And it ultimately lets us connect OneLake to Power BI directly. I just want to make sure that I'm showing you the updated drawing. Yes, it will come later, great. So that's the base level explanation of Direct Lake. It's a way to connect directly to OneLake in Power BI. So how should we think about this from a data modeling perspective? So I have, together with my good friend Mark from Netherlands, have been playing around with different ways of making data models, trying to make star schemas, one big tables, normalized structures, different ways of doing data modeling to see if somehow the best practices we already knew, if they changed because of the way that Direct Lake work. And to our experience, that's not really the case. It's the same good old best practices that we can still follow that gives the same performance in Direct Lake as well. We should be aware that with Direct Lake, we don't have Power Query anymore inside the data semantic model experience as part of that model experience. So we cannot, like we could do if we were to make a Power BI dataset half a year ago, we could transform our data on the way in and make some last step modifications. That is not possible with Direct Lake. We have to use the data one-to-one as how it is stored on one lake inside the Delta files. So we have to push that transformation back upstream to our upstream systems, which is honestly not necessarily a bad thing, because it just forces us to do something that was best practice all along. It's always been the mantra, let's push the transformations as far upstream as we can, but with Direct Lake, we're just being kind of forced to do it. So not a big problem if you ask me. And then finally, being forced to do that will open up new possibilities. So if anyone here comes from a Power BI only background of not having a data warehouse or not having a data platform or a data lake or anything, but just are used to doing full refreshes of Power BI, perhaps incremental refresh, well, pushing that transformation down to an actual backend system, an actual data warehouse or a data lake or a lakehouse or whatever we call it, will open up new possibilities of what you can do with your data. And one of the big ones could be that you can start storing historical data and store how the data is changing over time. Classical example could be, I see lots of business systems that are monitoring projects and project deadlines. And a lot of time when I ask clients, well, how can you see if you were actually on time or not? Oh, we just check the deadline and the actual finish date. That's fine. But did the deadline change over time of the project? We don't know. And most don't know because the systems themselves will override that value. So we don't have that value of what was the deadline when the project was started. Well, if you have a data platform, you can collect things like that and save them and have that historical data. So that's just one of many extra opportunities that opens up when you move towards not just using Power BI. So best practice goes from being the regular best practice around data modeling to, of course, also be a set of best practice around how we should build that data platform layer. And I know there's a lot of hype about calling it bronze, silver, gold, or raw standardized serving, or raw standardized curated, and I personally don't really care that much about semantics. I think it's more about actually deciding on those layers, deciding on a structure, and then follow that structure, and know why we have the different layers that we have. But that is also, of course, a scope for a whole other session in itself. But for raw data modeling itself, in our experience, general best practice to have a star schema, to have a proper data model, is still the same as always. Actually, we found that whatever used to be best practice is now just even more important. So things like bidirectional relationship, things like many-to-many relationships, things like overly complex DAX measures, those are just performing exponentially worse with Direct Lake than they do with an import mode model. So it becomes even more important to reduce that complexity and keep the data model simple. And again, keep the complexity and the transformations upfront to create a simple star schema data model, to make your DAX queries simple. And if you do that, well, then Direct Lake is actually running really well. So not much has changed. We're still a fan of star schema. I mentioned bidirectionals and many-to-many. Limited relationship, also something to avoid. Role-playing dimensions are excellent to avoid duplications, and calculation groups can be utilized to minimize redundancies. Yeah, so basically, nothing new here under the sun for data modeling. Do what we always do, but be even more careful about doing it properly. Let's try to, so that was a bit of the theory here about it. Let's try to make a Direct Lake model. Because one thing is to talk about it. Let's look at how it actually looks in real life. So I'm going to have to change my screen settings here. There you go. And we can go to a workspace. So the first thing to do to make a Direct Lake model is, of course, to get some data into our system. And this is not a session on end-to-end pipelines or data analytics platforms and stuff. So we'll skip that part, and I'll just show you that what I've done to do that is I have here an pipeline called ingest. That pipeline is connecting to some sort of source system. In this case, of course, it's a demo. Ah, thank you. Did it jump back midways, or?
Yeah.
Uh-huh.
The first thing you do, and then...
We'll try again. I'll keep these settings open in case it happens again. Anyway, we're in the workspace here. So the first thing we do is we need to get some data, and I'm going to skip that. So we'll just jump into, I've already ingested this. So I made here a simple copy data activity. It looks up a table in my database, and this table decides what kind of data I need to ingest. And in this case, I defined 6, 7 tables from my data source that I want to use for my data model. I then use some copy activities that are iterated over, and it's copying this data into my lakehouse. All of these things and more is separate discipline. Definitely look up on it, because data transformation outside of Power BI will be a huge thing in the future. But once that data is landed, I have a lakehouse that looks like this. So it has the data that I mentioned, and it actually has a little bit more, but ignore that for now. So it has these data elements that I mentioned. It's now part of the data lake. I can browse them if I would want to do that. And it hopefully will work. So I can see the data. That's fine. So the data set comes with its own default, the data lakehouse comes with its own default data set as well. So I can browse up here and say, for some reason, this data set or a semantic model is part of the SQL Analytical Endpoint UI. Don't ask me why this choice was made, but that's the choice Microsoft made. So if I want to change this default model, I have to go here, go to this model tab, and I can then change it here. And it's giving some errors. We can ignore that because we're not actually going to use it for now, but I could, regular experience, I could drag and drop and add these elements together to create some kind of basic default model. Now the default model is something we cannot opt in or opt out. We will get it every time we create a lakehouse, and it will just be there. And it's a little bit limited. We cannot do everything. We are kind of limited. So the way I see it more as an endpoint for my lakehouse. So I also have the SQL endpoint where I can query my lakehouse with SQL, but with this default data set, I can also query my lakehouse with semantic link through Python or something like that. So I can actually query the model itself with the relations that we've defined. So that's a neat thing to consider, but I don't consider this to be necessarily best practice for the actual semantic model we want to use for our reporting. And luckily for us, we don't have to rely on this, because we can create our own new semantic model based on this lakehouse. So I'll just give it a name. We can call it SQL bits. And I choose which table I want to include in it. So it should be this one, these ones. Which workspace I want to save it in, and confirm. And that's it. Once we have the data, we can easily create this semantic model. So some of the big limitations here is that I can only connect to one lakehouse. I can only choose the tables I have available here. I don't have the options to do cross lakehouse or cross warehouse models with elements from different. So so the lakehouse should have all the data that we want for our model if we want to use Direct Lake. And as you'll see here in the experience, we are also limited to only being able to do online modeling. So we don't have the possibility to open this model in our, I think I chose the wrong table here. Anyway, we'll survive. So we don't have the option to edit this from Power BI desktop. We're forced to do it online, and that comes with the all the limitations of having to do it online. So there are possibilities of some basic row level security, But as you will see here is yeah, no, that's fine. That's actually new. So we can do rollover security. That's nice. We can do calculation groups. We can do manage relationship. But I'm kind of limited to that. I don't have a bunch of all other options. So those are my options. So there are limitations to Direct Lake, to the features and functionality that we can use. But besides that, we can just drag and drop and connect our tables and create our relationships like we would usually do. So I've created this over the standard AdventureWorks model. And I'm not going to spend the time here stitching this together. I've pre-cooked this data set for us. So we have here the AdventureWorks data set where everything is added together, and we added a few measures. So I've added a symbol in sales order details. I added a simple sum of sales measures, and I added a complex measure with a bunch of things, just to test like performance on one or the other. I think we can all anticipate which one will run the fastest. But moment of truth. So I created this model, and I actually also prepared a report for this. So the curious thing here is, do we think that the whole idea that, what did Microsoft say? They said we have DirectQuery real-timeness together with import mode performance. So that is a very big, bold ask, or like mission. So let's see if that is true in real life. So we have here a data report made on this data set. And to make sure that I don't cheat by having something precast here, I can actually do a little trick here that will remove the entire data model from memory. So now this is as if I created it from the first time in just a few seconds. Great. It's an empty model now. And this report is now connecting to this data model as on a blank sheet and as the first time. So let's try to do something simple like picking a slicer and see how fast that updates. You see, it actually takes some time. And this one is not updated yet. The others are, oh, wow. Thank you. No, I do remember this one. Yeah. I actually do. We actually do. I've been in a company that had 2 cyber attacks in 4 months because we didn't have MFA. And after MFA, not a problem since. So I do love MFA. Great, back on track. So I had this error yesterday as well when preparing. It.
Still running off the same data source.
Yeah. But yesterday I had to log in 2 times, and that was it. Hopefully it's the same now. Anyway, as you saw, and this was not because of the login thing, it took actually quite a few seconds for it to load the first time. And that's because there's some magics happening behind the scenes. So when Microsoft is saying it's connecting directly to that data, that's actually not true. It is actually taking a copy of that data and pulling into memory to make it very fast. It just does that much faster than import mode has ever been able to do it, and it does it on a much lower granularity, so it can pick only the data we need, pull those into memory. Which means that when I then browse the data that I already browsed, it is going to be incredibly fast, because that data is now in memory, meaning that it is technically as fast as import mode because it is technically imported. But if I then click something else like this slicer, you'll see, oh, what the? This one. Okay, you don't see it, but it's actually going to be then slightly slower again because it has some of the data, but it needs to pull in a little bit of new data. So in import mode, we could only do table level import. So I could say specific table, I want to import that. And even that required us to use other tools than Microsoft Standard, Tabular Editor or something, some other external tool. But we could do table level refresh only. But with Direct Lake, it does it on a column level. So it looks at the specific columns I'm using and say, well, before you actually have to use this column, we don't care about pulling it into memory, which means it only has to take what it needs, and that makes it incredibly fast. And as you'll see, the actual user experience here of clicking around the things, trying to click with this one, or change my slices, is actually what you would expect from import mode. So it very much lives up to the whole as fast as import mode hype, except for the very first time that you're using it. And that's the compromise we will have to live with Direct Lake, at least for now. So that was the simple model. Let's talk a little bit more about the internals of it here. Because this is a simple model with a simple data set of not a lot of, it's not very great in size. And what we've already discussed now here is that it's an oversimplification to say that it just connects directly to the Delta table. It does. I call my query, it connects to the tables, but before it does so, it checks, do I already have this data in my cache? Yes, no. If no, then sends a request for the backend and actually fetches that data and caches it up into the model. And since Power BI was always built on similar technology as data lakes, it was actually not that much of a stretch to create an engine that can take that data and very, very quickly transcode it into the format that it needs in Power BI. So that happens incredibly fast. I mean, if you were ever to refresh a table before or a model before, you usually look into minutes of refresh time, where, as you saw here, the first time I clicked that slicer, it took 2, 3, maybe 4 or 5 seconds, and that was the actual import time. So that's the data set importing specific columns in few seconds. So that's the big innovation with Direct Lake, being able to pull that data into memory that fast. And this is, of course, made possible by being hosted on the Delta Parquet format. Question from Jon?
Multiple customers, and say, in terms of security, like say they have like subsets of each other, so one customer might have a larger level of access than another, but they each have a level of access to a given data. If they're all pinging the model, will it see, oh, we have a customer that's already queried this data?
That's an excellent question. So the question was, if we have multiple customers, or it could just be multiple users that needs different roles of access to the security model. So this model needs to import the specific data, the specific columns for that model to run. What happens then if you have those multiple customers? Are they then connected to a common shared data model, or do it make individual copies for each of them, and so forth? And the answer is as easy as it's disappointing, because row-level security and those sorts of features are not supported in Direct Lake yet. So that means if we are using security, it's going to fall back and actually just use DirectQuery instead. And DirectQuery supports the security model, but then you don't have the cache. So whether or not they're going to implement it the one way or the other, I have no idea, but they haven't implemented that yet. Great question, by the way. But what's making it possible is that we have this Parquet file. It's optimized as a column store, compressed file technology that really makes data take up less space, and it's column-based. And that opens up for the possibility for the Direct Lake engine to just pick those specific columns from those Parquet files. Another thing in Fabric as a whole is that the computes in Fabric, and this is limited to the computes in Fabric. So we have data flows, pipelines, notebooks, perhaps something else I may forget, but those are the 3 main computes in Fabric. And if we use any of those to write our data, to save our data into OneLake, it will by default have something called V-order enabled, which is an even further compression and optimization inside the Parquet files and Delta. So it's a little bit of technical nitty-grittiness, but it basically means that at the end of the day, that I demoed a 3 billion row data set. It used to take 416 gigabytes of data. Converting it to Parquet itself got it to 164. And then converting it to a Delta format with reorder enabled, it's down to 60 gigabyte. So that means that once the engine then after the fact has to move the data from one lake and cache it into the model, it needs to do it with much less data than if we were to do it from a CSV or a SQL Server or something like that. So it is, it's all those behind the scenes small innovations that really adds up to making Direct Lake possible. But question from the audience or?
Question from.
Oh.
Yeah. If we're using Direct Lake, is there any ability to create a measures table still? I could be one of your people still using measures tables.
Not without a little hacky approach.
Okay.
So the table needs to be there in your backend, but yeah. So you'd made a blank table in your data lake, which doesn't make any sense, but that's what you can do, and then you have a measure table. But you can still create measures like you could anyhow. Okay. Great question. And I don't think I repeated that question. So the question was if we could create a measure table in Direct Lake to store our measures in. Yeah. Great. Direct Lake doesn't work for all cases. It has limitations, and it especially has limitations around data size, data types, all of different things. And those limitations are on an ad hoc query by query basis. So we honestly don't know when we're creating a model if it will work or if it may fail. So this has been considered. So the thing is that if you ever do some sort of query, either some that's too large or using an exotic data type, thinking of it, I think it's things like geographical, longitude, latitude data types. No, it's some of those not often used data types that are not supported. If we have security on it, if we have, there's a bunch of other limitations. If any of these limitations are true, well, then it's going to circumvent Direct Lake, it's going to ignore the cache, and it's going to send that query through the SQL endpoint as direct query to the data source, which means it will run slower. But the good thing about this is that with Direct Lake, no matter what we do, almost no matter what we do, we will never have a slower experience than with Direct Query, because if we are sending a query that the engine thinks will be slower with Direct Lake, it is just going to pass it onto Direct Query. So that's kind of the lower bar. We can always assume that Direct Lake is going to be better than Direct Query, unless there are feature limitations between those two that we care about. Is there a way to monitor which queries are falling back to Direct Query? Yes, we can use the performance analyzer in Power BI itself to check if it does a SQL query or if it just uses a DAX query. I'll show that in just a bit. So we can definitely monitor that on the symbol level, and I'm sure you can set up monitoring logs for that in the backend as well. I won't cover that today, unfortunately. So, some of the things that can make it fall back: special data types, large volumes. If we do composite models, it's also going to make that fall back. And if we add any form of security on our lakehouse, including row-level security, thinking of it, not 100% sure if row-level security is supported or not, because it's a newly added. I didn't have that button the last time I ran this demo, so it may actually be supported today. But anyway, if you added security on your item level in your lakehouse, then it's not supported. Then it's going back to Direct Query, falling back to that. So another interesting concept here is, and I think the biggest limitation in Direct Lake is, I don't know if you noticed from the beginning that I wanted to start from scratch. I wanted to make the model slow again, and what I did is I actually went to the Power BI workspace and I refreshed the model. And the thing is, when we do that, we're clearing out the cache. So all the work it has spent on fetching that data, writing it into the cache, and preparing it for us. The moment we refresh the data set, it's going to wipe out that memory, remove it, and create the hollow data model anew. And the reason that we even have that possibility is this. Because we want direct lake, which means we want direct access to the newest data. So we are going to assume that this data will be fed with new files over and over. They may be every half hour, every minute, or every hour, but new files are going to enter our delta table. And the question is, what do we want to happen when a new file enters our delta table? The choice seems simple. Do we want it to include that data, or do we want to control when it includes that data? Do we want to manually have it refresh? Well, we've chosen to go for direct lake, so of course we want it to be direct, but that's not without problems or consequences. So imagine something like if someone accidentally updated their dimensional tables in the warehouse in OneLake in the delta tables. So you have updated your dimensions. They have new surrogate keys or something like that. But the update for the fact table didn't arrive yet. Suddenly you have an inconsistency between the two, because if you just make it use whatever new data is entering the system, it will adopt and get that new dimension table. But that will be a mismatch now with the fact table before that arrives, and that could have the report experience be ambiguous and inconclusive and have wrong data for a moment until that data arrives. So maybe we want to control this, and we have that option. But whenever we decide to do this, either automatically or by manual choice, whenever we decide to say, hey, we want to include this data, it is going to wipe out our cache data. So we will, every time we are taking in new data, our end users will suffer from this performance lag that we saw in the beginning. The first time they query the model, the first time they query any column, it will take a few seconds. It will be slower. So that's the trade-off here. We can control if this happens automatically. So there's an option on the model itself where we can say, do we want to keep it automatically up to date, or do we want to refresh it like we did with regular old Power BI models? And that's just an on and off option. So you can decide with your data sets if you want one or the other, but both are possible. Question from the audience?
How long can it be stale if you turn that off? How would you know that, like, overnight job thing?
If you turn this off, how long would it be stale? Yeah. Well, if you turn this off, it will never update with the new files unless you go manually and click refresh dataset, like you would expect from any Power BI model before. From within your dashboard? From within your Power BI service. Right. So I'll show you. Hang on. I mean, anything that it is a refresh of your model. So I can go here. If I didn't enable this, I can go here and click in the workspace. So it's in the workspace. So it's on the data set itself. It has to refresh, and I can do it similar to it is basically a data model refresh, like we've always been used to. I can set up a scheduled refresh as well. I can have it. Do it daily, or I can have it do several times per day. I can have it done weekly, and everything we can do with Power BI. So we can have it refresh like we would our import mode data sets. Great. So if you just have it refresh, the difference is that the difference is this. If I click refresh here, it's pulling in new data, and it's refreshing in 3 seconds. So that's the difference. Your refresh time, because you don't have to wait for that to refresh the actual data, it's just doing a metadata refresh. So you can technically refresh every 5 seconds if you want to. You could refresh every 10 seconds. even with a model that with import mode would take 5 minutes to load in the new data. The consequence is, of course, that you're just pushing the delay time to your end user, who has to then wait on when they do the reporting, they have to wait those seconds. But the big difference is that where you have to wait minutes for import mode to load the data, the user has to wait seconds for Direct Lake to cache that data. So the big difference is that Direct Lake is caching the data much faster. And the next follow-up question to that could be, well, why didn't Microsoft then just utilize the Direct Lake technology to make our import mode run 10, 20 times faster? And I don't have an answer to you because I have that same questions. I think it's about the limitations. We couldn't do that with all models, so it wouldn't be a good experience to say you need to limit yourself to these features to have this. But technically, you could use it as a regular import mode that just goes much faster. And if we have the time, I'll talk a little bit more about how you could do that programmatically. So there are things we can see in the metadata of our model. Things that can help us understand what's going on with this caching and how it's happening and all those things. And especially this query for the DMVs is quite interesting. So let's try to run it. First of all, before I run it, I want to show you something that's a little bit larger. So this was a small data set at VentureWorks. Everything is going to run fast when it's this size. So I've also tried with a bigger data set. Let's just ignore this, it's not working. So this is a much bigger data set. You see right now here it has 78 millions of rows. And if I click around here, and for example, I update the dates, you will see seconds of delay, even though this model has actually been cached before. Perhaps not, actually. We'll wait and see. It definitely has not been cached if it's taking this long. So it should take 10, 20 seconds or something. So right now it's caching a lot of data, because even though I'm only looking at slices that's showing 78 millions of rows, it has to cache the whole columns of the whole data set. And since I'm slicing on time, the data set is actually much larger than 78 million rows. So you see now here, 115 million rows, and it actually took quite some time to update some of the basic measures, and this more complicated measure is taking a very, very long time. And you will see that if I click around here, you're going to see similar small delays, but it's getting faster and faster the more I use it, because more data is entered into the cache. But this is not import mode performance. I mean, this is a large data set, but this is definitely slower than what I would expect from import mode. And initially I was disappointed with this, because I thought this is not a great experience, especially this one that just hangs around, never actually finishing. But the thing is that if I remove the date filter, it's kind of the same time it takes to do the same steps for the whole data set of 900 million rows. So this is also because this is an extremely large data set. And I wanted to benchmark this against, what if I imported this same data set into import mode? And can you guess which of them ran fastest? I cannot say, because import mode wouldn't let me import this large amount of data. Exactly. So what we're looking is we have a bad user experience because we're able to do something we were not even able to do before. So perhaps not that bad at the end of the day. But it's a large model, so it's also great for us to use as a way to dig into the metadata. Question while we wait for it.
Is that map using geography data types? Which you mentioned that could use direct lake, or is that just that long?
I don't remember, but there's nothing in the report that are falling back to DirectQuery. So either lat long are supported, or I didn't use them here. The question was if I was using special data types here that could make it fall back to DirectQuery, especially in the map with lat long. I think this is a city name column that I'm using, so it's not lat long. Need to log in again. I hope I don't have to do it 3 times this time. Great, and I'm just gonna grab the script from here. Not this one, this one. Fabric Labs, no, that's not it. Yellow taxi, there you go. We'll try to run it. It seems to be buggy. It's better, but not great. There you go. Great. I can work with this. So let's go back to our AdventureWorks data set. So I refreshed this before to show you what happened. And when I refreshed it, what it actually did was clear this cache. So what you see is dictionary size here. That's actually how much space the cache is currently taking, currently using. So when I start querying here again, and I just need to be able to force it to query something that's new, so I get rid of report level querying. Something like this should be fine. Sum of sales, yes. I can run this query again. And you can see now it populated with data. It cached some data. So what's interesting about this is that it's caching the different columns separately, and it puts that into memory. But you also have something here at the side called temperature. So if I go and refresh something like product ID here over sum of sales, and I just keep updating this visual. There you go. If I keep updating this visual, you should see here that one of the numbers, product ID, will go higher and higher in temperature. So before it was 23, and now it's 27. And as you'll see here is for the rest of them, actually if I don't do anything, they'll drop in temperature. So we have this functionality where every time we're using a column, well, it's being pulled into the cache to begin with, but then every subsequent time, the backend is going to raise the temperature and keep following along how much is this being used. So that to some point, if we have too much memory in our capacity as a whole, it can start removing some of the columns from memory, and it can target those that are least used and evict those from memory. So it's a really smart engine, especially to have that possibility of targeting most important columns and least important columns. And just because we are running completely out of time, I'll finish by saying as a tip to the whole how to manage this, can we turn it into an import level view? Well, we have the possibility here to check the cache. We can check which columns are used. We can check what is most used by the customers. We could theoretically have a notebook or a Python script or something that runs every time we're refreshing our dataset to just force it to import our dataset. Even the most important columns, or import the whole dataset. We could trigger that with just running some queries on those columns. So if we wanted to make our own import-like implementation where it just imports the whole data set whenever we refresh, but we want it to be much faster, we could utilize Direct Lake, send an API that refreshes the data set, send another API that just queries every column of our entire model, just a small query taking the top one row, and if we do that, it is actually going to import all the data, and it's going to do it much faster than the regular import mode. So that's possible to investigate what to do. So yeah, as a wrap up, all the things we talked about. We're running out of time. I'd rather spend the last minute on asking you for some feedback. And I'll share the slides with the event, so feel free to go in there and copy everything you've seen here. There's also like this complete picture of how all of the components play together. Please hand me some feedback. That would be so awesome. I mean, it helps the event improve, it helps me improve. We are 3, 5, 6, 15, 20, 30 people in the room. So please help me. I'll be disappointed if I have less than 10 reviews. And while you do that, I'd be open for one quick question, and we can go to the lunch break. So thank you. Yeah.
Thank you. Very good. With the fact that you can only consume a data model that's been prepared already,
Yeah.
is this going to push development back to
Absolutely.
developers who have access to all of the infrastructure and the fabric consumption? And kind of, is it going to be a problem for the systems and analysts?
Absolutely. And that's a good question, and I'll repeat it. With this push of us having to do transformation more upstream, will it also push the responsibility of that task away from the citizen developers over to those that have access to that back-end infrastructure? It did hit one of my, is it called pet peeves? Like, it is one of my in my daily life, and with most clients, I often see people talk about front-end and back-end. And if you ask me, there's a really big, important part that I would sometimes call the middle end, which is the data modeling part, that is sometimes being thrown across, shared across those two. I think that middle part of it is going to be increasingly more focus in the future, both around giving those citizen developers the right skills to still do data modeling in one leg with something like data flows Gen 2, where it's still the UI they know from Power Query, but give limited access. We don't have the options today in Fabric to say, you're allowed to do data modeling, but you can only use data flows Gen 2. We don't allow you to use notebooks. We don't allow you to use some other things. And I think that's a problem. I think we need to be able to give citizen developers part to a subset of the platform for that exact reason. So yes, I think we're going to see some noise around this going forward. Great, but people have put their phones down, so thank you all for submitting the feedback, and I've enjoyed this. I hope you learned something today, and let's go enjoy our lunch.